Morning to all of you. Myself M. Soundararajan, Assistant Professor from Department of Agricultural Engineering at Sri Shanmugha College of Engineering and Technology. So as a part of Unit 1, we have seen some fundamental topics in Lecture 1 video that is available in my channel. You can see that. So in that lecture, we had seen what soil is, what the components of soil are, and what all the soil forming minerals playing a part of soil are. And finally, we have how soil forming process occur through different weathering processes over a period. So in continuation of that, in today's lecture, we are going to see the soil profile and layers existing beneath land characterized by the particular properties of each layer. And finally, we will see an overview of the physical properties of soil as it plays a crucial role in engineering domain. Okay, all right. So let's see. So soil profile is a vertical cross section of the soil extending from the surface down to the unweathered rock. It displays all the distinct layers that have developed over a time. So each distinct layer is called a soil horizon. So in next slide we can see the soil horizons, different soil horizons detailedly. The profile tells the story of the soil's formation, composition and fertility, which is crucial for agriculture and environmental science. So here the important term which is regolith. So regolith it includes all the weathered materials like horizon, O, A, E, B and C horizons. So another term called solemn, it includes uppermost biologically and physically active layers that are horizon O, A, E and B horizons. So in next slide we can see the different horizons. So you can see the pictorial representation of soil layers which is existing beneath the earth. So that here I in the box I given the different horizons based on their uh, characteristics. So horizon O is commonly called as organic layer or humus, so which is dominated by organic materials like leaves, needles, decomposed plant, animal matters. So dark, it is in dark color. So most common this soil most commonly seen in forested area. So horizon A, uh, commonly called as topsoil. See, this soil is a mineral soil mixed with significant humus. Uh, this is darker in layers below, so rich in nutrients and where most biological activities occurs. So horizon E, which is commonly called as elevated layer, this is the zone of maximum leaching or elevation occurring. Um, it is a clay, iron, aluminum oxides, and organic matters have been washed out in this layer, so leaving behind a concentrated of resistant minerals like quartz, usually lighter in color than A or B, often found in forest soil. So next one is the horizon B, which is commonly called as subsoil. This is called zone of accumulation or elevation. The materials leached from A horizon and E horizons seen in this layer, such as clay, iron oxides, and other minerals, are deposited here. Order and more compact than horizon A. So the next one is horizon C. It's a parent materials, or we can call it commonly it as saprolite. This is the least weathered layer, consists of unconsolidated, partially disintegrated weathered rock. It's a lacks of organized structure and high organic content of upper layers. The next important one is ore horizon, which is commonly known as bedrock. You can see in this video, it looks like rocks. So this is the underlying unweathered solid rock. This is not considered soil, but is the source of material from which the soil sea horizon forms. There are different physical properties of soil. We divide it into two groups. The first one is major structural properties and the second one is secondary properties. The secondary properties are influenced by the major ones. The major structural properties are most critical properties directly affecting water and hair movement and root growth. The first one is soil texture. Soil texture is the relative proportion of the three minerals separates that are sand, silt, and clay. It is a permanent property that indicates or dictates the soil surface area, which influences the water holding capacity and nutrient retentions and drainage. The second one is the soil structure. It is the arrangement of sand, silt, and clay particles into stable secondary units called aggregates or beds. It is a dynamic property changeable by management that creates a pore spaces, allowing for good aeration, water infiltration, and root penetration. The third physical major structural property is soil porosity. The definition for soil porosity is the volume of the total soil occupied by pore space. Here we are pore space means voids. So these pores are filled with varying amount of air and water. The soil porosity directly linked to aeration, drainage, and water availability. So there are two type of pores. The first one is the macropores, which is generally in large size, allow the air and water to move quickly, which is not easily available for plant usage. The second one is the micropore, which is in a small size that holds the water tightly for plant usage. The fourth soil physical property is soil density. It means the mass. It is the soil density is the mass of soil per unit volume. The most commonly measured form is bulk density, which includes both solids and pore spaces. So in particle density, there is no pore spaces taken for measurement. So it is an important indicator of soil compaction. A high bulk density means low porosity and severely restricts root growth and water infiltration. Secondary properties mainly influenced by the major ones are major properties like soil texture, soil structure, soil porosity, and soil density. The interaction of major structural properties in soil will result in secondary properties. So the secondary properties often results from or error interaction of the primary structural properties. The fifth property from the secondary properties is water consistency or soil consistency. It means the soil's resistance to deformation or rupture. So it is typically described at different moisture level. For example, sticky in wet condition and friable in moisture condition and hard soil at dry condition. So it determines how easily the soil can be worked in tillage and the effort required for roots to grow. The sixth one is the permeability or infiltration rate. So both is referred for almost same, which is referred for ability of the water can move in the ground towards the gravity force by the gravity force. So it is the rate at which water and air can move through the soil profile. It is essential for managing surface runoff and ensuring water reaches the plant roots. So high permeability is typical for sandy soils and low permeability is typical of compacted or heavy clay soils. The seventh one is soil color. Soil color is measured using Munchel chart. That is, it is the visual hue, value, and chroma of the soil. That is three measures we can use for soil color measurement that are hue, value, and chroma. The soil color indicates other properties. Like if the soil is in dark color, usually means high organic matter it has. So if the soil is in red or yellow color, indicates the presence of iron oxides and good drainage. If the soil is grey and mottled color, that suggests poor drainage and waterlogged condition. The next property is temperature. Soil temperature means the temperature of the soil at a specific depth. It controls the seed germination and root development and the activity of the beneficial soil microorganisms. So in this slide you can see a diagram. This is the diagram is a Venn diagram illustrating how different categories of soil properties are interconnected and specifically how MPs impact them. Here the MP stands for microplastics. These three overlapping circles represents the three major group of soil properties. So first one is the chemical properties. I given some examples in the green colored circle uh, for chemical properties. These chemical properties relate to the chemical composition of and reaction within the soil. The first example for chemical property is soil pH. It refers for the acidity and or alkalinity of the soil, which affects the nutrient availability. Based on the soil pH range or soil pH, nutrient availability for plant growth is decided. So next one is organic matter. It means the amount of decomposed plant and animal materials. Organic matter is crucial for fertility and water retention. So the next two chemical property is nutrients in the soil. So nutrients are essential elements required for plant growth. For example, nitrogen, phosphorus, potassium are the some essential elements for plant growth. This last chemical property example is soil pollutants. Soil pollutants means that substances like toxic metals and organic pollutants that can harm soil health and life. The next one is the physical properties. I have given the example for physical properties in blue colored circles. The first one for these physical properties relate to the structural arrangement and mechanical characteristics of the soil. The first example is aggregate or soil texture. The structure or clumping of soil particles. There are different structures in the soils that are granular or blacky. So if the example is granular or blacky structures are example for soil structure. Then second one is the soil porosity. The volume of pore space or gaps in the soil is the soil porosity, which is crucial for air and water movement. The third physical properties of the soil is bulk density. It is a measurement of soil compaction. We are use the formula that is mass per unit volume for find out the bulk density of the soil. The last physical property given in the blue color the circle of physical properties is soil water. It is the amount of water held in the soil which is available for the plants. The third property is microbiological properties. These related to the living organisms within the soil and their functions. The first one is soil microbial community and diversity means it means different types of and abundance of bacteria, fungi and other microorganisms existing in the soil. The second one is the microbial activity. It is the rate at which microbes perform essential tasks like decompositions and nutrient cycling. The third microbiological property is microbial process. It is the functions like nutrients mineralization, nitrogen fixation, and organic matter breakdown. Uh, that is the examples for microbial process. The central dark brown overlapping area is the key focus of the entire diagram. The MP induced changes in the soil properties. Here the MP stands for, I told you that MP stands for microplastics. This central area indicates that the presence of microplastic in the soil has a simultaneous and interconnected effects on all three categories: the physical structure and the chemical reactions and the function of the microorganisms are affected by the microplastic, which is deposited by the humans in the soil nowadays in very adverse way. So it changes in the soil properties. So microplastic changes the soil properties. I think it's enough for today class. One thing I want to say, that the arrows pointing between the categories is emphasize the independency of the properties. So a change in one properties will lead to changes in the other properties. For example, if there is any changes in the physical structure of the soil, that also will lead in changes in chemical leaching and microbial habitat of the soil. So this is enough for today classes. I think you got what I'm trying to say and I'm trying to convey to you guys. So thank you.